Right, this is the second section of the hypothesis testing chapter, finding critical regions for the Poisson distribution. Okay, and let's draw like a little diagram to help us understand what these critical regions are. Okay, so what I'm going to draw here is these are going to be the values of x. So 0, 1, 2, 3, 4, 5, and it carries on like that. And what I'm going to have on the side here, if this is x, this axis is going to represent the probability up to x. Okay, so because it's a discrete distribution, let's say the probability of getting a 0 is this, or a 0 and a 1 is this. So they're going to get higher because it's cumulative. Like this. Yeah, now this sort of goes on. I've just drawn a bit of it, and let's say that these values here are 0.1, 0.2, 0.3, 0.4, and so on. Now, if I had a significance level of 20%, which is 0.2, then I would have some probabilities that drop below it. I can see that here and here, let's presume that's below the line, these probabilities drop below the significance level. So this would be the probability of x equals 0 or less than or equal to 0. And here this would be the probability of x less than or equal to 1. So my critical value, and this is like for a lower tail, would be x equals 1. Yeah, what does that mean? Okay, so below 1, I would reject H0. Above 1, okay, an observed value of 1, I would accept H0. That's a critical value. The critical region is basically the inequality. So I could say that for this one, when x is less than or equal to 1, I would reject H0. So this is about finding the values of x which are either going to cause us to accept or reject H0. Now on these questions you'll need to use the tables. It's quicker on the tables. You can use your calculator, and instead of pressing, because all the time we've pressed I think 2 for variable. Let me just get the menu up on my calculator. Yeah, number 1 is list, number 2 is variable on your calculator. Now we've used list variable, it gives us one value. So instead of using a table, you can press 1 instead and bring up a list. But it's more fiddly, it's easiest to use the table, and you'll find the table either in the formula book or on page 191 of the textbook. Yeah, but it's also in the formula book as well. An estate agent has been selling houses at a rate of 9 per month. He believes that the rate of sales will decrease in the next month. Using 5% significance level, find the critical region for a one-tailed test of this hypothesis that the rate of sales will decrease from 9 per month, where it's already said something about decreasing. So that's same information repeated. Right, so we start off in the same way. What is H0 and what is H1? So H0 is that the rate of sales hasn't changed. it's still 9. H1 is going to be that the rate of sales has decreased. It's less than 9. X is going to be the number of houses sold, number of house sales. And this is X is a Poisson distribution with a rate of 9. Now, what we would have done before is we would have said the probability of X less than or greater than a number and worked out the probability. This we go the other way around. So I want to find, because it's a one-tail test and it's about things decreasing, I want to find this value here, yeah, and I'll use the tables to help me find that, such that this probability here is less than the significance level of 5%. Now, even if you find that value straight away, I would always write down the value either side of it to show that you've used the tables. Yeah. So I'm going to go to the tables, page 191. I'm going to go to the bottom of half of the table, find lambda 9, and I'm going to go down the table and then stop when I get a probability that is greater than 5%. Now I can see that when I get to looks like 4, when x equals 4, let's write this down. So when I've got the probability of x less than or equal to 4, that is looking at the right value hopefully, 0.55 0.0550. Okay, that is greater than 5%. And the probability that x is less than or equal to 3, that is 0.0212. Actually, I wanted to do them the other way around, really. I think I looked at the wrong row. So it makes more sense that I'm going down the table like this. So this one should be 0.0550. That's greater than 5%. Just changing the order because you'd be going down the table, not up the table, really. And yeah, 3 was 0.0212, which is less than 5%. Right, so we go as far up to 5% as we can, but we can't go above it. So that means that the critical region, or our critical value, is 3. The critical region is when our observed value is less than or equal to 3. So less than or equal to 3 sales is going to cause us to reject H0. Right, part B, write down the actual significance level of this test. Okay, so it's actually 2.12%. Now, if this question was about he actually sold 2 houses, well, because 2 is less than 3, it's in the critical region, then I would reject H0. Okay, so let's write some stuff down, even though it's not asking us. So if the number of sales, houses sold, is 3 or less, what would we do? We will reject H0. If the number of sales was more than 3, we'd accept H0. There'd be no evidence that the house sales are decreasing, whereas 3 or less sales would be that there is evidence that the number of house sales is decreasing. Right, we've got this lady football player or striker who's normally scored 0.7 goals per game. She's been transferred to a new team and they want to see whether our rate of scoring goals has increased from 0.7. So they look at the number of goals she scored in 10 games. We're told we're going to be using a Poisson distribution with a 5% level of significance. We want to find the critical region for a one-tailed test. Well, we know it's a one-tailed test because it talks about an increase, not a change. And it repeats the phrase here that she's increased her rate of scoring from 0.7 goals a game. So let's start first of all by writing down what's H7. Well, that's H1. That's 0.7. That's what she got in the past. We want to see if there's been any change. In fact, we want to see whether that rate of scoring has increased from 0.7. Now they monitor 10 games, her first 10 games. So X is going to be the number of goals scored in 10 games. In 10 games. Okay, in which case X is going to be a Poisson distribution with a mean of 7, because if it's 0.7 a game and we're monitoring for 10 games, we can just scale up, and we're expecting a rate of 7 goals in 10 games. And what we want to find is, okay, at which number of goals can we say there's been an increase? So you want to find that critical value. So is it 8 goals? Is it 9 goals? Is it 10 goals? How many goals can we get to at which we say, okay, there's definitely been an increase? So that's the critical value. And we've got 5% level of significance. So what does that mean? Right, so we need to find a value of X greater than, let's call it A, where that probability is less than 5%. Yeah, when it's less than 5%, that probability, then we can say, right, okay, there's been some sort of change. Now we know that we can't work out that directly, so we'll work out the probability of less than or equal to. Now we need to find some numbers, and what we're going to do is we're going to work out those probabilities and see how close we get to 5% or just below 5%. Now, the number that we put here, because we've got 1 minus, we're really looking for a number here where the probability in the table, probability is close to 95% or 0.95. Okay, that's probably the most straightforward way of doing it. Let's go through the table in the book, which is on page 191. So on page 191, I find lambda 7, which is the 4th column in the bottom half of the table. And I'm looking for probabilities that are close to 0.95, so that when I do 1 minus that, I get close to 0.05. Now, so look for a value just below it. Right, now, if X is 10, so if I put 10 here, then what I'll end up doing is 1 minus the probability less than or equal to 10. Now, am I looking in the right column? No, I'm looking in one column. So 10 wouldn't be any good. I was looking at 6.5 column. 7 column, right, 11. Right. So if I go down to 11, that's close to 0.95. So I'm going to do 1 minus 0.9467. Let's see what I get. 1 minus 0.9467, I get 0.0533. Okay, that's close to 5%. Let's try the next one down. That's bigger than 5%. I really want to find the values either side of 5%. So now I'm going to go down to the next row, which is 12. So if I look at 12 in the table, that's going to be 1 minus 0.9730, 0.9730. So I can already see that's going to be less than 5%. So 1 minus 0.9730. Okay, that's 2.7%, 0.027. Okay, let's now interpret what we've got. So for the first one, when I worked out 1 minus the probability x is less than 11, that is actually the probability of x greater than or equal to 12. And that is 0.0533. And that is greater than 5%. Okay, so that's outside of the tail, outside of the critical region. But for the next one, where I do 1 minus the probability of x less than or equal to 12, that's actually the probability of x greater than or equal to 13. That's what you do to work out the probability of x greater than or equal to 13. And that is 0.027, which is less than 5%. And I want the greatest or the least value I can find that is less than 5%. So what does that tell me? It tells me that the, do I need a critical region? Right, so let's write down critical value. The critical value is x equals 13 or 13. So the critical region, I'll just write CR, is when x is greater than or equal to 13. So if we get more than or equal to 13 goals, we know that there has been an increase. Anything lower than 13 goals means that there's been no change, there's been no increase. It's just the same. Right, part B, this is an easy bit now. Write down the actual significance level. So that's basically the probability that I wrote down, which is 0.027. So the actual significance level is 2.7%. Now the last bit, that's just a bit of interpretation. That's just looking at the critical value and comparing it with 11. Now it says that she actually scored 11 goals in her first 10 games. Comment on this observation in light of your critical region, we can write down that 11 is not in the critical region. I'll just put CR. So there is no evidence to suggest the number of goals has increased. Right, an office finds over a long period of time incoming calls from customers occur at a rate of 0.325 a minute. They believe that the rate of calls has changed, two-tailed test, and the number of incoming calls during a random 20-minute interval is recorded. What do we need to do in part A? Find a critical region. So what number of calls is going to suggest a change? Two-tailed test. Now this time the probability in each tail should be as close to 2.5, so not below 2.5, but close to 2.5 as possible. Alright, so in this case, the mean number of calls is 0.325. We want to know, has that mean number of calls changed? Is it a not equal symbol to say that it's changed? In this case, X is going to stand for the number of calls, in 20 minutes. So X is going to be our Poisson distribution, where the mean number of calls in 20 minutes is going to be 0.325 times 20. And when we work that out, we get 6.5. Right, let's start by finding the critical value at the lower end by looking at the lower tail. So we're looking for a number to put in there where we get a probability close to 2.5%. Right, so when x is less than or equal to 1, we get, I'm going to write as a percentage, 1.13%. When x is less than or equal to 2, we get 4.3%. So always looking for a value below and above that. Now, if it wasn't as close to 2%, close as possible to 2.5%, and it was just a critical region, we would choose x is less than or equal to 1 because it's less than 2.5%. But here we need to find a value that's closest to 2.5%. So I'm going to do 2.5% minus 1.13%, see what that is, and I'm going to do 4.3% minus 2.5 and work out what they are. So 2.5 minus 1.3, 2.5 minus 1.13, 1.37%, so that's the difference between those two. And 4.3 minus 2.5 is 1.8%. So this one wins, this one here wins, it's closer, which means this is closer, which means that my critical region is the observed value is less than 1. So if the number of calls in 20 minutes is 1 or less, I can say there's been a change. Right, and let's now look at the upper tail. The upper tail one's always a little bit more tricky to work out. So I'm trying to find a value that's greater than or equal to something where it can be as close as possible, to 2.5%. Right, so now the way that we will work out these greater than ones is we work out a probability of x that is less than. Now what does that mean? I'm going to be doing 1 minus something, and what I want actually the number that I put here to be as close as possible to 97.5%, because 1 minus 9 or 100% minus 97.5% is 2.5%. So let's have a look, going down to the bottom of the table. So what can I see close to 0.975? Right, when x is 11, I can see that I've got 0.9661. Right, that gives me 0.339. Okay, that's 3.39%. Okay, right, let's go down to the next one. So you'll never, well, it's unlikely you're going to find the exact value that you want, but you're looking for values either side of that, one bigger, one smaller. So the next one down is 12. Okay, that's a little bit bigger than 97.5%, so that's 1 minus 0.9860. So 1 minus 0.9860. Let's do that right, 0.9860. Okay. And that gives me 0.014, so that's basically 1.4%. So which one is closer to 2.5%? This one here, bottom one. Whoops, don't want to highlight in black. That's not a good idea. This one here. Yeah, that is closer to 2.5%, and we'll just double check that. So if we do, actually it may not win, let's see. let's do the calculation first. So here I'm going to do 3.39 minus 2.5%. What's the difference? 3.39 minus 2.5. Okay, that's 0.89% difference. And this one's going to be 2.5 minus 1.4. I think it may be the other one that wins. Okay, that's 1.1% difference. Okay, so what does that mean? That means that this is closer. That means this wins. Now, if I'm working out the probability of x is less than or equal 1 minus the probability of x is less than or equal to 11, that actually means that I'm working out the probability of so this here is the same as the probability that x is greater than or equal to 12, isn't it? Yeah, the way to work out that will be 1 minus the probability x is less than or equal to 11. So here the critical region is x is greater than or equal to 12. So if the number of calls is more than or equal to 12 in 20-minute period, it means that there's actually been a change. Right, we're finally on part B here. Right, the actual significance level. Well, I just need to add this probability and this probability together. So that's going to be 1.37 plus 0.89, 1.37 plus 0.89, and that gives me 2.26%. Sorry, that's not right. That was how I worked out the difference, so let's get rid of that. What I actually meant to say was that we need to add these probabilities together. Yeah, that one, I've got too much highlighting, that's the problem. And this one, they're the ones I need to add together, the actual probability. So let's correct that. So that will be 1.13 plus 3.39. So 1.13 plus 3.39, and I get 4.52. See, the actual significance level is 4.52%. We'll look at part C. It says the actual number of calls recorded in a 20-minute period was 13. Right. Is 13 in the critical region? Yes, it is. It's in the rejection region. It's bigger than 12. Okay, so we'll write something like this. Since 13 is in the critical region, or you could call it the rejection region. Reject, hate 0, and then something like there is evidence to suggest the number of calls has changed. There we go. Okay, you should now be able to do exercise 4B on pages 65 to 66 of the textbook.